Hey everyone, and welcome. So, we've got this incredibly powerful thing, AI, right? It's changing everything. But that power, it comes with a huge question. How do we keep it safe? How do we make sure it's used the right way? Well, that's what we're digging into today. The playbook for keeping modern AI in check. I mean, it's a question you've probably thought about, right? AI is literally everywhere now. But what's stopping it from just going rogue? What are the invisible rules keeping it all in line? That's the mystery we're unpacking today.
Okay, so here's the plan. We're going to talk about what controlling AI even means, then dive into the AI-Specific Playbook. After that, we'll hit security's greatest hits, see how they create a two-layer defense, and finally, we'll peek into the future. Let's get started.
All right, first up, controlling the modern AI. And the first thing you've got to know is there's no single magic button here. It's not one solution, it's actually a whole collection of smart techniques all working together. And in the biz, we call these controls. And just look at this. It's like a whole toolbox, right? You've got things called prompt firewalls, encryption, rate limiting, a whole bunch of stuff. It might seem a little overwhelming, but the cool thing is we can actually sort all of these tools into two big buckets. And here they are. This is the core idea, a two-pronged defense. Think of it like this. On one side, you have these brand new, custom-built tools made just for AI's weird and wonderful brain. And on the other side, you've got the time-tested classics, security's greatest hits, that protect the whole house the AI lives in. All right, let's dive into the really cool new stuff first. This is the AI-Specific Playbook. These are the tools built from the ground up to handle the unique challenges that these big AI models throw at us. So you can think of these three, prompt firewalls, model guardrails, and prompt templates, as the AI's personal bodyguards. They're a specialized team, and each one has a very specific job. Let's break them down. First, we've got prompt firewalls. The best way to picture this, it's like a bouncer at a super exclusive club. It's standing right at the entrance, checking every single person, or in this case, every prompt, that tries to get in. If it sees a jailbreak attempt, someone trying to trick the AI into breaking its own rules or injecting some malicious code, nope, blocked. They don't even get to talk to the AI. Okay, so if the firewall handles what comes in, model guardrails handle what goes out. I love this analogy. They're like the bumpers in a bowling lane. They're these internal rules that just nudge the AI's answers back to the center, keeping it on the right track. They make sure it doesn't spit out toxic stuff, leak private info, or just completely wander off topic. And last in this group, we have prompt templates. This one's all about structure. So instead of letting a user just type in a big, messy paragraph, a template forces the request into a specific format. It's basically like making the AI fill out a form instead of reading a free-form letter. It just massively cuts down the room for tricky attacks because everything is clean and predictable. Okay, so that's the new school. Now let's talk about the other half of our strategy, the old school. These are the classics, security's greatest hits. We're talking about techniques that have been battle-tested for decades, and now they're being put to work to protect AI. So if those AI-specific tools are protecting the AI's mind, these traditional controls are all about protecting its home. We're talking the servers it runs on, the databases it learns from, the whole network. This is the foundation, the bedrock that everything else is built on. And kicking things off is an absolute classic, access controls. And this goes hand in hand with something called the principle of least privilege. It's super simple, really. Imagine you have a key card at work. It doesn't open every single door, right? It just opens the ones you need to do your job. That's it. This makes sure that every user, and even the AI itself, has the bare minimum permissions they need and not an ounce more. Then you've got encryption. Everybody's heard of this one. It's basically just scrambling data into a secret code. This protects it everywhere, whether it's just sitting on a hard drive, what we call at rest, or when it's flying across the internet in transit. So even if a bad guy gets their hands on it, all they see is a bunch of useless gibberish. Useless without the secret key, anyway. Now, this one is so important. Data integrity controls. Think about the tamper-proof seal on a bottle of aspirin. You know that if that seal is broken, you shouldn't trust what's inside. This is the digital version of that. It's a way to prove, without a doubt, that the AI's training data, or even the model itself, hasn't been messed with. And rounding out our greatest hits is rate limiting. Simple idea, but super effective. It's basically the system acting like a bartender who has to cut someone off. By limiting how many times a single user can ask the AI for something in, say, a minute, you stop attackers from just overwhelming the system and shutting it down. It's a lifesaver.
So we've got the new AI-specific stuff, and we've got the trusted traditional stuff. So how do they actually work together? Let's put the puzzle pieces together. And this is the whole point. It's a two-layer defense, and you absolutely need both. The traditional security, that's the foundation. That's protecting the AI's body, the servers, the network, all the hardware. But then the AI-specific stuff comes in to protect the AI's brain, its logic, its behavior, the way it thinks. Put them together, and you get a system that's secure from top to bottom. All right, so where do we go from here? Because if there's one thing we know about security, it's that the job is never, ever finished.
And if you take away one thing today, let it be this. Securing AI is not a one-and-done deal. It is a constant cat and mouse game. The people defending these systems have to keep innovating, because you can bet the people attacking them are doing the exact same thing.
And that leaves us with one last big question to chew on. As these AI systems get smarter and smarter, well, so do the attackers. It's a constant arms race. So what comes next? What's the defense we haven't even thought of yet that we're going to need to protect the AI of tomorrow?